This frightening looking object is the remains of a bronze propeller. It was fitted to a boat and someone forgot to check that the sacrificial anode was fitted correctly, or maybe the anode had simply eroded away to nothing. So what's all this about sacrificial anodes? I guess most of you have them fitted to your boat, but why do you need them? Well, here's a little experiment to show you what happens when you connect two dissimilar metals together and immerse them in seawater. This glass container is filled with a fairly strong salt solution, just ordinary table salt, the nearest thing I can get to seawater in my kitchen. And here I have two screws, one made of stainless steel and the other of bronze, and they are connected to wires, and I'm going to immerse them into the salt water. So that's a bit like your propeller shaft, which is made of a form of stainless steel, and your propeller, which is usually made of bronze. Now the interesting thing is that when I connect the other end of the wires to a meter, you can see that we have generated a small voltage. We've made a battery. This phenomena has been known for a long time. The very first battery was invented by Alessandro Volta in 1800. He took alternate discs of copper and zinc and piled them one on top of the other, separated by discs of cotton or cardboard soaked in brine, salt water. This pile was the first time that a constant source of voltage and current was produced, and led to the further investigations in electromagnetism and other wonderful effects. Now, if I switch the meter to read current, you can see there is a small current passing from one screw to the other, and this continues 24/7. All the time the two screws are connected by the wire and immersed in the salt solution. This causes galvanic corrosion, which is defined as an electrochemical process in which one metal corrodes preferentially when it is in contact with another in the presence of an electrolyte, the electrolyte in this case being salt water. Metals are defined within an anodic index, which tells you how noble they are, the most noble being gold and the least magnesium. Most propeller shafts are made of stainless steel 316. Bronze is an alloy of copper and tin. Looking at the anodic index list, the stainless steel is the most noble, followed by copper and then tin. So you would expect that the first to corrode with the tin, leaving just copper in the bronze. So what does this mean to our bronze screw? Well, over time, the tin leaches out from the bronze, leaving the soft copper behind. These screws have been in the salt solution for a few weeks now, and if you look at the bronze screw and compare it to a screw that hasn't been immersed, you can see that there is quite a difference in colour. The one that has been immersed has turned quite pink. That's because the tin has taken part in the electrochemical reaction, leaving the copper behind. And that's what's happened to this propeller. Over time, the tin has leached out and left the softer copper behind, which has eroded as the propeller whirled round. Well, we don't want that to happen to our propeller, do we? So what's the answer? If we look again at our anodic list, you can see that zinc is further up and less noble than tin. So if we electrically connect a block of zinc to the circuit and immerse it in the salt water, then the zinc will take part in the electrochemical reaction rather than the tin within the bronze. So we sacrifice the zinc to protect the integrity of the bronze, hence the name Sacrificial Anode. I hope you're still with me. If this video is useful, please do consider subscribing. So that's the theory of it all, but how do you put that into practice on your boat? Well, you probably have one or more anodes on your boat already. Mostly, I guess, the bolt-on torpedo sort. Here's the one on Zephyr 4. It's bolted to the hull, but it's not sufficient to just have one bolted onto your hull. It also needs an electrical connection between the anode and the parts you are trying to protect. Those bolts go all the way through the hull and appear inside. You can see that the two bolts are connected together and that there are wires connecting the engine cooling seacock and also wires to connect the other seacocks along the hull. The propeller is connected via a wire to the engine and then through the gearbox and the propeller shaft. Don't be worried by the apparent corrosion of the connections to the anode bolts. I smeared everything with lana coat and natural grease to protect them from moisture and prevent corrosion. That's why they look a bit brown. It's not rust. You can tell whether your anode is doing its job by taking a good look at it when your boat comes out of the water. There should be some signs of erosion, often with a rough surface. If it looks like this after a year, then you should worry. No erosion means it's not protecting your bronze parts. Maybe it's no longer electrically connected. Take a look inside the hull. It is not unusual to find that the connectors have corroded away, leaving the anode electrically isolated from your bronze fittings. Back in the 1970s, when I got my first cruising boat, the only anodes for sale were the versions of the bolt-on variety. But soon after, though, shaft anodes appeared. They are tightly clamped to the propeller shaft, and because they are very close to the propeller, they make a good job of protecting it. Zephyr 4 didn't have a shaft anode when I bought her, but I thought it might be a good idea to fit one. They're not expensive, and I think it was a good decision. This is the shaft anode after a year. As you can see, there is considerable erosion. Nearly half of it has disappeared. I now replace it with a new one every year. If you go to the chandlers nowadays, there are simply dozens of specifically shaped anodes available, mostly designed to fit on or close to a specific propeller or fitting. An example of that on Zephyr 4 is the ones that are fitted directly to the hub of the propellers in the bow thruster. Here's the old ones, 3 years old, and here's the replacements. They are held in place at the centre of the propeller by a stainless steel bolt tightened up with an Allen key. Lastly, here is an example of a temporary or removable anode. This one came from an aluminium sailing boat, and when it is moored, this is clipped onto a fitting and the anode dropped into the water, where it protects the propeller, the fittings, and also the aluminium hull itself. So there you are. That's why you need anodes. You don't want your propeller to end up like this. It would be even worse if your bronze seacocks turned to soft copper. Make sure your anodes are electrically connected, and worry a lot if they don't erode. By the way, the nasty propeller was loaned to me by boat breakers, who do a fine job of disposing of unloved vessels and recycling any useful parts. Take a look at their channel, it's interesting stuff. That's it then. Thank you for watching. I hope it helped to demystify sacrificial anodes and their use. I'd be grateful if you clicked on the like button, and if you subscribed, it would make me ever so happy. Just click on my ugly mug down there. Bye bye.